Start now.
We are going to begin about analog and digital electronics lab. For doing this lab, we need to know about the digital trainer kit, which we are going to use for all the lab experiments that we do for digital circuits. This is the trainer kit that we are going to study about use for the experiments. At the onset, there is a button at the top here. You need to switch it on. Once you switch on the button, you first have to check whether it has been powered on or not. To check that, just move the toggle buttons to high. Once you move that, you'll see that the LED is glowing. There is one more LED to indicate whether the digital trainer kit is on, and that is at the bottom corner. This implies that the trainer kit is on. Now, let us look into the input and output buttons or knobs which are available on the trainer kit. We have two output signals. One, the output LEDs. These red knobs are going to help you to see the outputs. If the LED is not glowing, it indicates that it is logic 0. If the LED is on, it indicates that it is logic 1. So, we have another set of output to be seen, and this is called as BCD2 decimal or a 7-segment display. On this particular trainer kit, we have two 7-segment displays. One onto the left hand side, the other onto the right hand side. It has got 4 connectivities to be done, which have been named A, B, C, D. So you have 2 7-segment displays and 10 LED displays to check the outputs on the trainer kit. To give the inputs to the digital circuits, we have 10 input signals. These are called as toggle switches. The switches can be toggled from high being 1, low for a 0. We also have 4 IC bases on this trainer kit. This is one IC base, this is the second IC base, third, and this is the fourth. So in all, we can install 4 ICs onto this trainer kit. If we need additional ICs to be installed, we can make use of the breadboard given at the bottom. So on this breadboard, we have to give the power supply and we have to install the ICs. So we can have as many number of ICs that we want, and we can make use of this. Now let us look into the other pins which are available. We have pins which are called as used for supplying the clock signals in sequential circuit design. And here we have 1 Hz, 10 Hz, 100 Hz, and so on. So these are the clock signal pins which are available on the trainer kit. Just below that, we have the power supplies. Please note, we are going to use 5 volts for all our digital experiments. Until and unless mentioned, do not use the 12 volts which is given on the board. 5 volts is plus 5 volts is red and ground is 0. So now we have a nomenclature to follow in digital circuit on this kit that red always implies 5 volts and black gives us ground. We also have plus or minus 12 volts available on the kit. Red here stands for plus 12 volts, black stands for 0, and green stands for minus 12. We are not using the 12 volts until unless it is mentioned to us. So now, after knowing the power supply points, let's move on to the clock pulse which can be supplied on every pulse base. This is called as a monopulse. This device helps us to supply only one pulse at a time at the press of the knob. So when I press this knob, only one pulse is going to be generated. Pulse are of positive edge triggered and negative edge triggered. If you need a positive edge triggered, you need to do the connectivity to high. If you need a negative edge triggered, you need to do the connectivity to low. So we have high for an upward pulse or a positive edge triggered pulse, a low for negative edge triggered pulse. We are going to use this in sequential circuits. Now let us look into what are these IC bases. I'll take this particular base and explain to you how to install an IC on the IC base. This is called as the IC base, and these are the pins which have been drawn onto the knobs. On this IC base, for every IC base, you will find that you have a red knob onto the top indicated as VCC and a ground, that is the black knob here. Plus 5 volts and ground available on the kit have been drawn into these knobs. You do not have to connect to the power supply extra which is there on the trainer kit. So all the red knobs on the trainer kit will have plus 5. All the black knobs on the trainer kit are ground pins. You can connect anywhere you get plus 5 and ground on each of these. So now, knowing where are the plus 5 points, VCC points and the ground pins, let us look into what is the total size of the IC base. On this IC base, I can install an IC with 20 pins, not more than 20 pins. And the numbering have been written out here. These numbers indicate all the pins which are there on this. Now let's look into how and what is an IC. An IC is an integrated circuit which internally has got many pins. At the onset, we are going to study about a 2-input NAND gate. Every IC will have a number associated with it, 74. These ICs that we are using in the lab are National Semiconductor ICs, and we are using low Schottky devices. The IC that we use now is 7400, and here this manual will tell about the details, all its electrical characteristics, connection diagram and general description along with the function table. This 7400 stands for quad. Quad means 4. 2-input NAND gates. So inside the IC there are 4 NAND gates. 1, 2, 3, 4. Now let's look at what is an IC. This particular 2-input NAND gate is a 14-pin IC. This IC has to be read. It has got 14 pins. To read the IC, we start from the left uppermost corner. Hold the IC with the notch being upwards. We have left hand side top corner is pin number 1. Then we have pin number 2, 3, 4, 5, 6, 7. We move on to the other side. 8, 9, 10, 11, 12, 13, 14. So this is a 14-pin IC. Please note, IC has to be installed with the notch pointing upwards. After you know this and the pin diagram that is given in the manual, you have to identify every pin and do the connections accordingly. Please note, you cannot by heart and do any wrong connection. If you interchange the ground, which is pin number 7, and pin number 14, which is VCC, the IC is going to burn out. So with a note of caution that the first connection that you do to the IC is VCC and ground. VCC is pin number 7 and ground is pin number 14. After knowing the internal diagram of the IC. So now we know that this particular IC has got 4 NAND gates within this. Now we'll learn about how to install this IC onto the IC base. To install the IC onto the IC base, see to it that you are holding the IC with the notch pointing upwards and push it from the topmost pin on the IC base. Note, push it from the topmost pin. You cannot push it, plug it, install it anywhere on the IC base. So here, now we are going to push the IC onto the base from the top. Hold it and push the lever down to lock the IC. You have to ensure that the IC does not move after pushing the lock. So now we have learned how to install the IC. As I said, the first connection that I am going to do onto the IC is always VCC and ground. To do the connection, we have patch cords. These patch cords help us to do the connectivity. So these are what? Connecting wires or patch cords. As I said, VCC and ground are the first connectivities that I do, and with the 2 ends of the patch cords, I am simply going to plug in on VCC. After it is installed correctly, as I said, after knowing the pin diagram, I know now that pin number 14 is VCC, so I am connecting it to 14. Now how do I know that this is 14? This is pointing to pin number 20. As I said, after installing the IC, I start with the pin number 1 here points to pin number 1 here. Pin number 2 here points to 2. 3 here points to 3. Similarly 4, 5, 6 and 7. After 7 we do not have ICs. Even though there are slots here, we do not have ICs there. So after 7, just opposite to that, this becomes 8. So this is pin number 8, this is 9, this is 10, 11, 12, 13 and 14. Please note, the numbering on the IC base is for a 20 pin IC. If you are installing an IC less than 20 pins, then the right hand side numbers do not coordinate with the pins or the number that has been written here. So you have to be very cautious. After pin number 7, opposite to pin number 7 is 8, 9, 10, 11, 12, 13 and 14. So now the connectivity that I have done with the patch cord is VCC connected to pin number 14. So now I have supplied the VCC pin. We have 2 patch cords, 2 colored patch cords in the lab. We also have black colored patch cords which we normally use for connecting as ground pins. So this is pin number 7. Now this has to be connected to ground. How did I know pin number 7 is ground? With the help of pin diagram. So now the IC has been connected. At times in the lab, the patch cords are going to be insufficient. So we make use of single strand wires. These are called as single strand wires. To do a connectivity with single strand wire, you need to open these knobs. You can unscrew these knobs, push the single strand wire through it. There are small knobs, holes within that, and tighten this knob in such a way that this does not fall on the wire. The connectivity should be on the wire and not the plastic, and you have to just take a slight push to ensure that the connectivity is correct. So this is how you can make use of a single strand wire for connectivity. Now after knowing what are the wires connectivity that we have, we now need to study about ensure about whether whatever wire I have used is working in right condition or not. So now we make use of another device that is called as a digital multimeter. This is a digital multimeter which is used for measuring current, voltage and resistance. It also has one more feature wherein I can check for a diode or a wire continuity. To switch it on, I have to press the power on. Before that, you should know that there are 2 wires which need to be connected to it. As I said, Black always stands for ground, and this is the common terminal, COM. This is common. So first I'm going to use this knob and I'm going to push it correctly into the slot. And since I'm just checking for continuity of the wire, I'm going to use the knob which has got an indication of a diode or a continuity. So this is what I'm going to make use of. Once these two knobs have been placed, I need to set what is the measurement that I'm going to do using this multimeter. Since, as I said, I'm going to use this for checking the continuity of the wire, I'm going to keep it at the diode signal or resistance signal that has been, ohm signal that has been shown here. Now I'm going to switch this on. Once I switch that on, I need to press the select button, and if I just short these two, I should get a beep sound. So this ensures that my selection on the multimeter for continuity of wire is correct. Before I do any connectivity, I need to check the continuity of wires. There are all the chances that these patch cords may be unplugged in between, because many of us pull it from the wire to dismantle. So now, before I start the connectivity, I am going to check for connectivity of these wires. You can use any knob and touch it across these two this way. So moment I touch, I get a sound. This shows that the wire is continuous from this end to this end. So all the wires that I am going to make use of in my design, I am going to check for the continuity of wires, including the single strand wire. How do you check the single strand wire? Touch both the ends of the wire onto this knob. You get a beep sound. If that sound occurs, then this wire also has got a proper continuity. So please use all these wires while doing the connectivity. So now we are aware of how to do the connectivity on the digital trainer kit.